All right, let's just dive right into this, because today we are talking about a thought experiment that, well, it kind of messes with the very fabric of existence. So I want you to forget everything you think you know about the universe being this smooth, continuous thing. We're going to explore something called the resolution limit of reality.
So let me just start by asking you a really basic question. Is our universe perfectly smooth? I mean, we tend to imagine space and time as being infinitely divisible, right? Like this perfect, flawless canvas where all the laws of physics do their thing. But what if that fundamental assumption is just wrong?
And this is where it gets really interesting. The source material for this whole idea proposes something radical. It says, hey, you know how our physics equations kind of fall apart at really extreme scales? Maybe the math isn't the problem. Maybe the problem is resolution. And that one little question, oh man, it changes everything.
To really wrap our heads around what this can mean for, reality, let's start with something we're all familiar with. We'll kick things off with an analogy we can all get, the digital world's limit.
This is something you already know just from using your phone or your computer every day. In any digital system, everything has a limit. There's no such thing as true infinity inside the code that runs our modern world. And here are two perfect examples. Think about your TV screen. No matter how fancy it is, how 4K or 8K, it's still just made of a fixed number of pixels. You literally cannot show any detail that's smaller than one of those tiny dots. And it's the same for, say, a video game engine. No matter how powerful it is, it can only calculate a certain number of possibilities. It has a ceiling.
So this whole idea boils down to one key term: resolution. It's just the finest level of detail that any system is capable of showing, or even telling apart. On your screen, that's a pixel. In a game, it might be the tiniest possible step your character can take. It's the absolute fundamental building block of that system.
Okay, you with me? Digital systems have a resolution limit. Got it? Now this is where we take the big leap. So get ready, let's talk about reality's maximum resolution.
This is where it gets a little bit mind-bending. Let's take that whole digital analogy we just talked about and apply it to, well, to everything. Just imagine for a second that our reality works the exact same way. That it's not this perfect, infinite thing, but it's actually a system with its own built-in limitations.
And this really shows you the shift in thinking. For hundreds of years, the big idea was that the universe is this flawless, continuous mathematical space. But this new idea, it says, nope, it's more like a digital screen. It's a system that has a maximum resolution.
So what does that actually mean? It means there's a hard limit, a fundamental boundary on how much detail can physically exist in any given space. It means there's a pixel size for the universe itself, a point where the very idea of smaller just stops making sense.
So, if reality has a pixel count, what does that imply? What are the consequences? What happens when you get to the very edge of that resolution? Let's explore what's going on both below and beyond that limit.
As long as we're operating inside this cosmic resolution, everything is fine. Below the limit, things are stable. The laws of physics work, atoms stick together, things behave the way we expect them to. This is the world we see and touch every single day.
But what happens if you try to describe something that needs more detail than the universe has to give? Well, once you go beyond that limit, structures just stop being realizable. They simply can't form. It's exactly like trying to draw a perfectly smooth circle using like 10 giant Lego blocks. The system just can't do it.
And here is a super important distinction. It's not that these structures are logically impossible. Not at all. You could probably write down the math for them, and on paper, in the perfect world of pure mathematics, they would make total sense.
No, the reason they can't exist is way more fundamental. They can't exist simply because reality itself doesn't have the capacity to build them. They're impossible because reality cannot resolve them. The universe in this model is basically a finite information system, and at some point, it just runs out of bits and bytes, so to speak.
I mean, this whole idea just blows the doors wide open for speculation, doesn't it? It forces us to ask this really deep question about what we can know and what we can't. So, for our final thought, what can't be resolved? And this is the thought I really want to leave you with. What kind of things might exist out there that we can simply never, ever see? Not because they're too far away, but because our reality literally doesn't have the pixels to show them to us. What kind of beautiful, complex patterns are just forever beyond our grasp because they're too fine-grained for the universe to even render? It's a pretty wild and, honestly, a pretty humbling thought.